So, dear students, now we will discuss about that the electrode potential in case of what D black elements. So, first we should know what is meant by electrode potential. The electrode potential is nothing but the potential developed when the metal is in contact with solution of its own ion. So, for example, zinc is there, Zn should be is in contact with 1 molar of Zn2 plus ions. Okay? The potential developed when the metal should be in contact with solution of its own ion, then that potential is called electrode potential. So, what is standard electrode potential? Standard electrode potential is nothing but what? The potential developed when the metal should be in contact with 1 molar of its own ion at exactly 25 degrees Celsius after the development of what? Electrical double layer. Electrical double layer is nothing but what? There is a formation of what? 2 layers. So, there is a charge which is created on the metal ion layer and the charge which is attracted by the metal from the solution. Means, so if Zn is in contact with Zn2 plus, Zn it's having a tendency to lose the electrons, means Zn it undergoes oxidation, it becomes what? Zn2 plus by losing electrons. Those released electrons are accumulated on the surface of the metal. Negative charged electrons are accumulated on the surface of the metal. Then, so this negative charged layer, it can attract the positive ions in the solution. Positive ions in the solution means what? Zn2 plus. So, totally it forms an what? Electrical double layer, positive layer and negative layer. So, due to formation of what? Electrical double layer, then that potential will generate, that potential is called standard electrode potential. The standard electrode potential for Zn it becomes what? Minus 0.76. Like that, if you go for copper, I mean, we know that the SRP value for copper is what? Plus 0.34 volts. Why? If the copper which is in contact with solution of its own ion, means copper is in contact with Cu2 plus ions. Copper is in contact with, metal is in contact with its own ion, that is what? Metal ion. Then there is a formation of electrical double layer here. So, the Cu2 plus ions in the solution, they can gain electron, it becomes what? Cu. So, if Cu2 plus can gain electron becomes Cu, during that those metal ions go and accumulated, those metal ions in the solution can accumulated on the surface of metal. So, it becomes what? Positive layer. Then the solution it is having an cupric ion is nothing but what? We are placed in an cupric sulfate, means SO4 2 minus ions are there. Those SO4 2 minus ions are surrounded the metal ion layer. Totally it develops an what? Electrical double layer. Due to formation of an electrical double layer, the potential will be generated. That potential we may call the standard electrode potential. What is standard electrode potential? The potential developed when the metal should be in contact with solution of its own ion. So, after the attainment of electrical double layer, okay. So, that potential we may call it as what? Standard electrode potential at exactly 25 degrees Celsius. Now, so we know that in case of what? Electrochemistry. So, what about the electrode potential SRP value for different electrodes? So, SRP for different electrodes like lithium there, Li bar, Li plus, okay. We know that the SRP value for this is so nearly minus 3.05. Then K bar, K plus, so potassium which is in contact with its own ion, then so that value it is around minus 3. Then Na bar, Na plus, we know that their electrode potential is what? Minus 2.95. Then so if you go for magnesium which is in contact with its own ion, their value is minus 2.44 volts. Then so Al bar, Al3 plus, so it is minus 1.66 value. Then Fe bar, Fe2 plus, we know that it is minus 0.44. Then H2 bar, H plus, Pt. So, this value it becomes what? 0. Then Cu bar, Cu2 plus, we know that value that is plus 0.34 electrodes, then Ag bar Ag plus, it is plus 0.81 volts. Then Au bar A3 plus, that value is plus 1.66. F2 bar F minus, that value is plus 2.8 volts. This is what? The electrode potential of our different metal electrodes. So, we should have some knowledge about that, the electrode potential and the reactivity. So, as we know that in electrochemistry, those metal electrodes which are above that of hydrogen means those electrodes having a negative SRP value, they having a tendency to lose the electrons. They having a tendency to lose the electrons. Those metal electrodes which are below the top of hydrogen in the electrochemical series, or those are having positive SRP value, yes, they can gain the electrons. Then, so those having negative SRP, they can undergo oxidation easily. Means when the metal is in contact with its own ion, means metal can lose the electron, it becomes what Mn plus by losing electrons. Those metal having an what SRP value is positive, so they having a tendency to gain the electron, means metal ion is there, it is having a tendency to gain electron, it becomes what metal. Then, so these electrodes, they having a tendency to lose the electrons, means they can act as an good reducing agent due to loss of electron. They can act as an good reducing agents. These metal ions, they having a tendency to gain the electron, hence they can act as a good oxidizing agent. What is meant by reducing agent and what is meant by oxidizing agent? One which reduces other substances itself undergoes oxidation. It can reduce other substances, means it can add the electrons to other. Why? By losing electrons. So it is an oxidizing agent. Oxidizing agent means what? It can oxidize the others, but itself undergoes reduction. Itself undergoes reduction is nothing but what? There is an addition of electron, that is called reduction. So there is an adding of what electrons to the metal ion, becomes what metal. So the tendency is called reduction. The reduction is nothing but, so these elements, they can act as an oxidizing agent, means they can oxidize the others, but itself undergoes reduction. Then those metal electrodes having an negative SRP, they are highly reactive. They are more reactive. Those metal electrodes having a positive SRP, they are less reactive. Okay, so we know that in our daily life, sodium is what? Highly reactive. When it is exposed to the air, immediately it can form an oxides, carbonates. Okay, but gold, it is less reactive. Even though gold is with water, it does not react. Why? The SRP value is positive. So it is highly reactive. Why? Their SRP value is negative. Yes, you should know the applications of those, the SRP values. Now we will come to the electrode potential in case of our 3D series of our elements. So 3D series of elements from scandium to zinc. So what about the electrode potential in case of those 3D series? So before that, how to calculate the electrode potential in case of our 3D series? The electrode potential, standard electrode potential can be calculated by using one formula. One is the enthalpy of atomization, or nothing but what? Sublimation, plus the IE1, ionization enthalpy 1, plus IE2, ionization enthalpy 2, plus delta H of hydration. If you add that delta H of atomization, ionization enthalpy, and then delta H of hydration, finally if the value is negative, then these elements, they can undergo what? Oxidation, means they can act as good reducing agents, or nothing but what? They are more reactive. If if by adding those, if the value is what? Positive. If the value is positive, then those elements, they are less reactive, means they can act as a good oxidizing agents. Okay. So, we should calculate these. What are the delta H of atomization, ionization enthalpy, IE2 and hydration. We know that these two. IE is nothing but what? Amount of energy required to remove the electron from the outermost shell of isolated gaseous atom, that is called IE1. What is IE2? The amount of energy which is required to remove the electron from monopositive ion, then it is called IE2. Now, what is meant by delta H of atomization? Delta H of atomization is nothing but amount of energy which is required for the formation of atoms in the gaseous state, or nothing but the amount of energy which is required to break down the 1 mole of compound into its atoms, that is in the gaseous state, that is called enthalpy of atomization. Amount of energy which is required for the formation of atoms in gaseous state, that is called enthalpy of atomization. Now, what is meant by hydration? Hydration is nothing but what? The amount of energy which is liberated when there is an accumulation of water molecule on its surface. Means if metal there, okay, if metal it is in the gaseous state, okay, so how many molecules of hot water that they are accumulated on its surface? Means M becomes what? It is in the aqueous state. During that, how much amount of hot energy which is liberated? That is called delta H of hydration. Amount of energy which is liberated when there is an accumulation of water molecules on the surface of that metal ion, that is called delta H of hydration. So, here, so first thing is delta H of atomization can take place, means metal is there, whether it is in the solid state, okay, so it can be converted to what? Metal, it is in the gaseous state, that is called delta H of atomization. Then that metal is there, it can lose 1 electron, okay, it becomes what? M plus, it can lose 1 electron, it becomes what? M plus, that is called IE1, that is in the gaseous state. Then, so M plus is there, that is in gaseous state, it becomes what? M2 plus, it is in gaseous state, okay, that is called IE2, okay. Then, so either M plus or M2 plus becomes what? Hydrated, means what? So Mn plus is there, plus aqueous, means there is an accumulation of water, it becomes what? Mn plus in aqueous. Here the delta H value is negative. So in these two conditions, delta H value is positive. Here also delta H value is positive. Okay. So if this delta H of atomization is more, IE1 is more, IE2 is more. If delta H of hydration is less, means the negative value means during the accumulation of water, the amount of energy liberated is less, then IE1, IE2 and delta H of atomization is more. Finally, the electrode potential it becomes what? Positive. Okay. If the electrode potential it becomes what? Positive, then those metal electrodes are less reactive. They can act as what? Good oxidizing agents. So, in case delta H of hydration is more, amount of energy liberated during the accumulation of water is more, and moreover IE1 and IE2 or delta H of atomization is less, then finally we can get it an answer delta H is negative, I mean E0 value is negative. If the E0 value is negative, then those elements are highly reactive, nothing but what? They can act as a good reducing agent. So, on the basis of the summation of what? Delta H of atomization, IE1, IE2 and delta H of hydration, we can calculate the E0 value. So, finally we can get it either negative value or positive value. Okay? Yes. Now, so we will compare the E naught values for those 3D series of elements or transition elements. So, first let us discuss about that M becomes M2 plus, means the metal becomes what? Divalent metal ion, means when the zinc rod is in contact with its own ion, it becomes Zn2 plus, or the Cu2 plus, it becomes what? Cu. So, what are the comparison of the electrode potential? You see, in case of our titanium, it is minus 1.63, means more negative. Then vanadium, it is minus 1.18, chromium, it is minus 0.90, Mn minus 1.18, Fe minus 0.44. So, cobalt minus 2 point, this is minus 2.5, this value is plus 0.34, but it is minus 0.76. Just we can compare these two. Why for copper it is positive, why for Zn it is negative. So, for copper Cu becomes Cu2 plus or Cu2 plus becomes what? Cu, their SRP value is positive, but for zinc it is negative. Why? So, we will see here the zinc is negative value, negative when it comes delta H of hydration should be more, or the IE1 and IE2 value should be less, or delta H of atomization should be less. Okay, then only, so we can get it on what? Negative value. You see here delta H of atomization is more, but E1 though negative. E1 though negative is nothing but what? IE1 and IE2 value is what? Very, very less. So, simply we can calculate that. If delta H of atomization is 200, IE1 value is what? 290. So, IE2 it becomes what? 400. Then, if delta H of hydration, it becomes what? Minus 1200. Then finally, answer it becomes what? Negative. Okay. So, why that zinc is negative SRP value? The reason is here the delta H of atomization is more, delta H of hydration is more negative, and moreover IE1 and IE2 value are less. If the IE1 and IE2 value are less, finally we can get it on what? Negative value. Okay. So, here what he had given Zn, I mean for Zn it is 906 is given, 906 plus 290 around 1200 plus 400 means nearly it becomes 1300 plus 400, 1700. So, we can write, so minus 800, 1800. So, finally answer it becomes what? Negative value, nothing but what? So, it becomes what? Highly reactive, means it acts as a good reducing agent. Then, so you compare that copper. In case of copper, the SRP value is plus 0.34. When it is plus 0.34, the delta H of hydration, negative hydration value is less, but delta H of atomization IE1 and IE2 should be more. Okay? If these three values are more, but this is less, then finally we can get it on the value of what? Positive. If the value is positive, yes, then it is on what? Less reactive element, means it acts as a good oxidizing agent. So, you see here, so how to compare that IE1 and IE2. Okay, IE1 value is 745, IE2 value is very high. If IE2 is very high, delta H of atomization is also very high, but delta H of hydration value is very, very less. This negative value is less. These two values are very high, then finally answer is positive, means what? It is an less reactive or nothing but what? It is a good oxidizing agent. Like that, we can compare any one. So, Mn becomes what? Mn2 plus. Mn becomes what? Mn2 plus, where IE value is less. Okay. If the IE1 value is less, but negative SRP value is more. See, if IE1 or IE2, these two values are less. Why that IE1 and IE2 are less? Because Mn becomes what? Mn2 plus by losing 2 electron. Their configuration is 4s2 3d 5. So, by losing those 2 electron, immediately it can attain the configuration of 4s0 3d 5. it can attain stable configuration by losing those 2 electron. Okay. Then, so I1 value should be, I1 and I2 value should be less. If I1 and I2 values are less, then automatically delta H of hydration is more. So, we can get it an negative, that is what, minus 1.18. So, if you go for iron, it is minus 0.44, the negative value is less. Why? The hydration value is, negative hydration value is less, but IE1 and IE2 values are more compared to the top at Mn. You see here. So, in case of at Mn, so this is IE1 is 762 and that IE2 is 1561, means, so compared to these two, the IE value is very high. If the IE value is more, delta H of hydration is less, then automatically we can get it on lesser negative or nothing but what? Positive values. Okay. Therefore, the SRP value for iron, it becomes what? Minus 0.44. So, you see here, then vanadium it becomes what? Minus 1.18, means V becomes what? V2 plus. V configuration is what? 4s2 3d3, then it becomes what? 4s0 3d3 by losing 2 electron. So, we know that, as we know that earlier, if it is D3 configuration, it is more stable. To attain the stability, V becomes what? V2 plus. Okay. So, V becomes V2 plus means the E value, amount of energy required to remove the electron is less. Automatically, these two values are less, then finally, the negative value which becomes what? More. Then, so if you go for that chromium, then IE value is, compared to vanadium, it is less. Why? So, you see, in case of chromium, Cr becomes Cr2 plus. So, this is 4s1 3d4 3d5, okay, Cr2 plus. So, the Cr becomes Cr2 plus, it is very difficult. Why? Cr becomes Cr plus is nothing but by losing 1 electron from 4s. Cr2 plus means what? It should lose 1 more electron from D5. D5 is more stable. To remove that 1 electron from D5 configuration, it requires more energy, means the second IE value is what? Very, very high. If the second ionization value is what? Very high, means IE2 is very high, then automatically, then we can get it on lesser negative or nothing but what? Positive values. Okay. Therefore, so in case of what? Chromium, IE value is, E0 value for chromium is less than that of, negative value is less than that of what? Vanadium. Then, so we will go for M3 plus bar M2 plus. Compare the two elements. So, in case of cobalt, M becomes M2 plus is negative, but M2 plus becomes M3 plus, that value is what? 1.97. Like that, in case of what? Mn, M2 plus bar M, that is what? Minus 1.8, but M3 plus bar M2 plus, it is plus. The reason is Mn becomes Mn2 plus. So, Mn configuration is 4s2 3d5. Mn2 plus configuration is 4s0 3d5. It can lose these 2 electrons, finally it can attain the d5 configuration, it is stable. So, it can easily lose the electrons, nothing but what? IE values are less. IE1 and IE2 values are less only. If IE2 and IE1 values are less, automatically negative values are more, means delta H of hydration means negative value is more. Negative value is more means it is highly reactive element. Okay. Then, so if you go for Mn2 plus becomes Mn3 plus. You see, Mn2 plus means what? 4s0 3d5. Mn3 plus is nothing but 4s0 3d4. Okay. Is it possible to remove the electron from d5 configuration? So, it is very difficult to remove. Why? because it is in the stable state. Why all the set of d orbitals are completely half filled? Once all the set of d orbitals are completely half filled, then the element is more stable. So it is difficult to remove that electron from the d orbital, means IE3 value is very high. IE3 value for Mn is very high, you see, 3260. If IE2 is more, then automatically compared to delta H of hydration, these IE values are very high, means positive values are more, then negative delta H of hydration is less, then automatically the answer it becomes what? Positive. That is what? Plus 1.57. Okay. Then, so you compare this even in case of what? Vanadium. Negative value for M2, M becomes M2 plus, it is more, but it is less. Reason is vanadium there configuration is 4s2, 3d3 becomes V2 plus, okay, by losing 2 electron from 4s to attain more stable configuration, that is D3 configuration. We know that. So in case of what? D orbital, there are 2 set of orbitals are there. One is T2z set and one more is what? EZ set of orbitals. EZ set having an higher energy. So T2z set of orbitals are having lower energy. So once the orbital having an less energy, then the element is what? More stable. D3 configuration is nothing but more stable by losing 2 electrons. Means, so to attain the stability, it can easily lose the electron, means IE values are less. But if you go for V2 plus becomes V3 plus, M2 plus becomes M3 plus. During that, M4s0, 3d3 becomes 4s0, 3d2. So it is very difficult to remove the electron from more stable configuration of D3, means the IE3 it becomes what? Very high. IE3 value for vanadium is high compared to IE2 and IE1. Then, so if IE value is more, automatically the answer becomes either less negative or it becomes what? Positive. The electrode potential is less negative value compared to the top what? V bar V2 plus. Okay? Yes. So like that, in case of what? Copper, okay, Cu bar, Cu2 plus bar, Cu3 plus, we can't write. Okay, we cannot write this configuration. I mean, what? Cu2 plus becomes what? Cu3 plus, because as we know that the stable oxidation state of what? Copper are only +1 and +2. We can't write +3. Okay. Yes. Now, so let us concise those questions. So what is the comparison of what? The electrode potential in case of what? 3D series of what? Elements. So to calculate the electrode potential, so we should know the formula, that is the summation of what? Delta H of atomization, IE1, IE2 and nothing and hydration enthalpy. Okay. So usually hydration enthalpy value should be negative. IE1 and IE2 are positive. Even delta H of atomization is also positive. Why? Delta H of atomization is nothing but amount of energy which is required for conversion of what? 1 mole of compound into its atoms in gaseous state, or nothing but sublimation. Sublimation is always, the value is positive. IE1 or IE2, whatever it may be, IE is nothing but what? Energy required to remove the electron. Required is nothing but what? Always delta H should be positive. Hydration is always accumulation of water, it is an adsorption process, it is always negative. Delta H of hydration is negative, IE1 and IE2 are positive, this is also positive. Okay. So when does the element having a negative value? Means the delta H of hydration should be more negative, but these values are positive, means higher values. If this value is more higher than that of hydration, then answer it becomes what? Positive. If the hydration value is more negative than that of what? These values, then the answer is negative. If answer is negative, then the elements are more reactive, means they can act as a good reducing agent. They can lose electrons easily. If the answer is positive, When does positive values we will get? The delta H of atomization IE1 and IE2 should be more, but delta H of hydration is less. Then we can get it positive. If it is positive, they are less reactive, means what? Oxidizing, it acts as an what? Good oxidizing agent. So once again, we'll realize that. So for Mn, M2 plus, for Mn it is minus 1.18, it is very high negative value. The reason is Mn becomes what? Mn2 plus, it becomes easily. Why? The E1 and I2 values are less, delta H of hydration is more, okay, to attain the stable configuration, hence the value is negative. But Mn2 plus becomes what? Mn3 plus, it is positive value only, okay. Why it is positive? Mn2 plus is more stable configuration. From that stable configuration, it is difficult to remove the electron from dipositive ion. Means IE3 should be very high. If the IE3 is very high, then automatically IE values are more, means delta H of hydration should be less, then answer should be positive. Okay. So like that, copper and zinc. So zinc it is negative, but copper is positive. Why the copper is positive SRP? Why it is positive? The answer is, so Cu should be become Cu2 plus. So Cu configuration is 4s2 3d 4s1 3d10. Cu2 plus means what? 4s0 3d9. Means here, so after losing one electron from 4s, it should lose one more electron from D, means IE2 value should be very high, delta H of hydration is less, then automatically we can get it and answer is positive. But in case of Zn, we can get it negative value. Why it is negative? In case of Zn, Zn becomes Zn2 plus, means it is 4s2 3d10 configuration. So 4s2 3d10 becomes 4s0 3d10 easily by losing 2 electron from 4s. IE1 and IE2 values are very less to attain the most stable D10 configuration. So IE1 and IE2 values are less, means delta H of hydration automatically it is more negative, then the answer should be negative only. Okay. So like that, how to compare the electrode potential in case of what? 3D series of what elements. So they will ask the simple questions. So among Mn2 plus, Mn3 plus, Cr2 plus, which is oxidizing agent and which is reducing agent? They will ask. So is it Mn3 plus is an reducing agent or oxidizing agent? Like that, is it Cr2 plus is an reducing agent or oxidizing agent? So what have to do? How to write the electronic configuration first. So Mn configuration, we know that Mn configuration is 4s2 3d 5. Mn3 plus configuration is 4s0, it should lose 3 electron 3d4. Okay. So Cr2 plus, Cr configuration is 4s1 3d5. Cr2 plus is nothing but it must lose 2 electron, one from 4s, one from 3d, it becomes 4s0 3d4. Both are having d4 configuration. We know that in ionization enthalpy, either d orbital should be d5, or should be d10, or should be d3, then the elements are more stable. If it is completely filled or completely half filled, R should be D3, means all the electrons should be in the T2Z set, then the element should be more stable. Okay. So here either these two elements should be D3 configuration or should be D5, then the element should be more stable. We know that, so compared to Mn3 plus, Mn2 plus is more stable. So Mn3 plus becomes Mn2 plus, means configuration is 4s0 3d5. So Mn3 plus becomes Mn2 plus, how? By gaining 1 electron. So gaining 1 electron means what? It undergoes reduction. It undergoes reduction means what? It acts as a good oxidizing agent. What is oxidizing agent? One which oxidizes others but itself undergoes reduction, then it is called oxidizing agent. Oxidizing agent is nothing but one which oxidizes other substance but itself undergoes reduction. Means Mn3 plus becomes Mn2 plus by gaining 1 electron, then it can attain the stable configuration. So, D5 configuration, hence it acts as an good oxidizing agent. Therefore, we can write MnO compounds. Means in case of MnO, it should be +2 configuration, oxygen is -2. Okay, it is stable. Then, so in case of what chromium, Cr2 plus it becomes what? Whether Cr2 plus becomes what? Cr3 plus, or so it should be becomes what? Cr plus. So usually we know that Cr3 plus is more stable. Okay, +2 become +3 by losing 1 electron. So losing 1 electron is nothing but what? 4s0 3d3 configuration. Okay, we know that D3 configuration is also stable. So it can lose 1 electron. It can lose 1 electron means what? It undergoes oxidation. Losing of electron is called oxidation. Okay, one which undergoes oxidation means what? It acts as a good reducing agent. Yes. Okay, Cr2 plus becomes Cr3 plus by losing 1 electron. Losing 1 electron, why? D4 becomes D3. D3 is what? More stable than the top what? D4. It can lose electron means it acts as an, it undergoes oxidation. One which undergoes oxidation nothing but what? It acts as a good reducing agent. Therefore, among Mn3 plus and Cr2 plus, Mn3 plus acts as a good oxidizing agent, Cr2 plus it acts as a good reducing agent. Okay, like that. So we can see that Zn becomes Zn2 plus, whether it is an oxidizing agent or reducing agent. Zn becomes Zn2 plus, it is an reducing agent only. Why? So Zn becomes Zn2 plus, by losing electron it becomes what? 4s0 3d5 3d10 configuration, more stable configuration, means it can lose electron, hence it acts as a good reducing agent. Okay, like that we can predict the oxidizing property and reducing properties of what? Those elements. We can predict the reactivity of what? Those elements. So how we can predict the reactivity or the oxidizing and reducing properties? That is on the basis of what? The electrode potential. Okay. Now, so we'll go for the stability of those 3D series of elements in the form of halides and oxides. Okay. Yes. Stop. Okay, dear students. So we'll go for stability of what? Halides and oxides of 3D series of elements. We know that the stability should be explained on the basis of formation of halides and oxides on the basis of the lower oxidation state and higher oxidation state. We know that these transition elements can exhibit an variable oxidation state. Why they can exhibit an variable oxidation state? Because the energy difference between the 4s and 3d orbitals are very, very less. After losing 1 or 2 electron from 4s, immediately they can lose the electron from 3d, hence they can exhibit an what? Variable oxidation state. Therefore, they can form an halides and oxides with different oxidation state. Those transition elements can form an halides and oxides with different oxidation states. We know that the lower oxidation state for scandium, I mean what? Those 3D series of elements, it depend upon the number of electron in 4s orbital. So in case of scandium it is +2, titanium +2, vanadium +2, chromium +1, Mn +2, iron +2, cobalt +2, because it can lose 2 electrons from 4s. Like that, nickel +2, copper +1, Zn +2. The higher oxidation state from scandium to iron, we know that it depends upon the sum of electrons in 4s and 3d. Okay? So here 2 plus 1, 3 up to 3, 2 plus 2 up to 4, like that, 1 plus 5 up to 6, 2 plus 5 up to 7. But higher oxidation state start from iron to Zn, it depend upon the sum of electron in 4s and unpaired electrons in 3d. Not all the electrons, unpaired electrons in 3d. So here 2 there, 4s electron, unpaired electrons are 4, 2 plus 4 up to 6. But here we can't write plus 5. Because so it requires more ionization energy to remove one electron during the oxidation state of at plus 5 state. Then so like that, if you go for Zn, it is plus 2 only. Why it is plus 2? So by losing 2 electrons from 4s, it can attain the more stable configuration. So according to that oxidation state, we can write. Usually, so for halides, we can start from, if titanium is there, okay. So their higher oxidation state up to plus 4. We wrote halides, Ti, X2, okay, plus 2 state, plus 3 state and plus 4 state. Here for vanadium, we can write up to plus 5 state. Means F is minus 1 into 5, minus 5, it should be plus 5. This is minus 1 into 2, minus 2, it should be plus 2. For chromium, the higher oxidation state, it may go up to plus 6. So here we wrote, it start from plus 2, it may go up to plus 6. Okay. Then, so for manganese, it is an exceptional, the oxidation state, it start from plus 2 to plus 7, we can write up to plus 4, but in oxide forms, we wrote up to plus 7. Okay. It is highly exceptional and most important question. So that is why in case of halides, we can write MnF4 only, but not MnF up to MnF7, we can't write. But the same plus 7 oxidation state can be written in its oxide form, but not in halide form. It is unstable, but it is more stable compound. Then in case of iron, means manganese onwards, the higher oxidation state, it may go up to plus 6, plus 5, plus 4, but we can write the more stable state is up to plus 3 only, that is from iron onwards, okay, maximum up to plus 3. Here also we can go for oxides of those metals, means we can write maximum up to plus 3 state. So here the question is, why Mn does not exhibit on what plus 7 state in its halides, but the same Mn in its oxide form, it can exhibit on what plus 7 state. So if Mn, we can write it, okay, in the form of MnF7, okay. So MnF7 is nothing but what it can form and what 7 metal fluoride bonds like this. If we can write Mn2O7, Mn2O7 if we write, okay, or nothing but what you can write MnO4 minus, both in case of what MnO4 minus and Mn2O7, the oxidation state for Mn is plus 7 only. So Mn, it forms a multiple bond with oxygen, okay, it forms 3 double bonds with what oxygen, then one more MnO, Mn, oxygen bonding is there, okay, like this, yes. So it looks like 2 tetrahedral structures, okay. So this Mn, it forms 1 tetrahedral structure, this forms 1 tetrahedral structure, and moreover it can form multiple bonds. Mn with oxygen, it forms a multiple bond, it is more stable. But here Mn with fluorine, it forms what single bond, then so the stability of what MnF7 is less, but in case of what Mn2O7, the stability is more. Why? Due to formation of multiple bond, that is the reason. So they will ask the question, why Mn does not form an MnF7 even though oxidation state for Mn is plus 1. But in case of Mn2O7, the oxidation state we can write up to plus 7 in its oxides. The reason is it forms on multiple bonds with oxygen, but it does not form on multiple bonds. Okay. Then, so like that stability wise, we can go for vanadium, we can start from plus 2 and up to plus 5. For these elements, we can write up to plus 3 only, not more than that. So why? The one of that reason is, so iron onwards, the oxidation state goes on decreasing. Why? Because there is an pairing of electrons. The electrons undergoes pairing. The number of electrons which are involved in the bond formation is less only. And moreover, they can form some more covalent nature. Because as we move along the period, atomic size decreases. Okay. Now, so we'll go for oxocations and oxoanions. Oxocations, before that, we'll discuss about that. Among metal halides, which metal halides are more stable? Whether those metal halides they are in the higher oxidation state or those metal halides are in the lower oxidation state, they are stable. Usually metal halides in the lower oxidation state, are less stable. But metal halides in the higher oxidation state, they are stable. Therefore, we should compare that CuX and CuX2. In case of CuX, copper is plus 1. In case of CuX2, copper is plus 2. You see here, so CuX is unstable according to this statement. So those are in the lower oxidation state, they are unstable, but higher oxidation state they are stable. So this is unstable, but this is stable. And moreover, CuX is highly stable compound in aqueous media. Why? CuX2 means the Cu is in the higher oxidation state, nothing but plus 2. It is more stable in the aqueous media. Why? So the reason is the hydration enthalpy is more. Yes. The hydration enthalpy in case of what CuX is more than that of what CuX. Therefore, Cu plus 2 compounds in aqueous media, they are more stable. But one exceptional condition is there. So what is that exceptional condition? We know that CuX means what? Those are in the lower oxidation state, they are unstable. But if there is an iodide form there, Cui there, but it is unstable compound. I mean more stable compound than the top what? Cui2. You see, the compounds are in the plus 1 state, they are more stable, means copper is in the plus 1 state or lower oxidation state is unstable, but copper is in the plus 2 state, it is stable, means those compounds are in the higher oxidation state are stable. But in case of iodide form, Cui2, it is less stable compound, but Ce2I2 is more stable compound. It is an exceptional condition that Ce2I2, it becomes what? I mean, if there is an Cui2 is there, it can be decomposed into, yes, it becomes, so Cu2I2, 2Cu I2 it becomes what? 2Cu I2 becomes what? Cu2I2 plus I2. Or we can write Cu2 plus there, plus I minus there, it becomes what? We can write Cui or nothing but Cu2I2 plus I2. Yes. So, it is an exceptional condition. We should remember one thing, those metal halides are in the higher oxidation state more stable than the top, those metal oxides, metal halides are in the lower oxidation state are less stable. But in case of copper is in the form of iodides, only in the form of iodide, it is less stable than that of what? Copper is in the form of what? Iodide in +1 state. Okay? So, it can decompose us into Ce2I2. This is more stable compound, more stable, but this is an what? Unstable compound. Only in case of what? Iodide form. Okay? But not in the form of chlorides or fluorides. Then, one more question is, why these metal means transition metals either in halide form or in the form of its oxides, okay, either in the halide form or in the form of what oxides, they can form some more stable compound. Okay. Why? These metal halides and metal oxides are the compound which is formed by using halogens and the compound which is formed by oxygen, they are more stable compared with what other compounds. The reason is, so this fluorine and oxygen are highly electronegative elements. Okay. So, they can easily attract those metal ions. They are highly electronegative elements, they can easily attract those metal ions. Hence, the compounds of what halides and oxides, they are more stable components. Now, so we will go for oxocations and oxoanions. Let us see what are oxocations and oxoanions. The example for oxocations of vanadium, that is V5, the oxidation state of what vanadium is 5, nothing but VO2 plus oxocation. I mean oxygen is -2 into 2 nothing but -4 become +1 when the oxidation number for V should be +1. Okay. Then, so vanadium is in the fourth, I mean the oxidation state is 4, nothing but VO2 plus. You see, oxygen is -2 become 2 plus when vanadium should be +4 oxidation state. These two compounds are called oxocations. Those oxoanions are, we know that MnO4 minus, Cr2O72 minus, FeO4 2 minus, ferrates. These are all, we may call it as what? Oxoanions. How those oxoanions are formed? Those oxoanions are formed when those metals can react with oxygen under higher temperature. Those metals can react with what? Oxygen under higher temperature, they can form some oxoanions. Okay. So, you see these oxoanions are also more stable, oxocations and oxoanions are also more stable. When example vanadium, it is in the oxidation number 5, means it is in the form of what? VO2 plus. Vanadium is in the 4 oxidation state, that is in the form of what? VO2 plus. The manganese is in the form of what? The oxides, that is what? MnO4 minus, Cr2O72 minus, FeO4 2 minus. So, these compounds are called oxoanions. So, let us discuss about those, the acidic and basic nature of what these metal oxides. How we can predict the acidic and basic nature of what? Acidic and basic nature of what those? Usually metal oxides having higher oxidation state are acidic. Metal oxides having lower oxidation state are basic in nature. You see, those metal oxides, they are in the higher oxidation state, they are acidic in nature. Those metal oxides, they are in the lower oxidation state are basic. How, sir? Very simple. We know that in case of ionic equilibrium, we know the concept of Arrhenius equation. We know the concept of Arrhenius equation. We know the concept of what? Lowry-Bronsted theory. We know the concept of Lewis theory. Okay. What is an acid according to Arrhenius? What is an base according to Arrhenius? One which dissociates to give proton in aqueous media, that is called acid. One which dissociates to give OH minus ion in aqueous media is called base. We know that according to Lowry-Bronsted theory, LB theory or modern concept theory, so one which dissociates to give H plus proton both in aqueous and non-aqueous, then it is called acid. So according to Lowry-Bronsted theory, base is nothing but one which accept a proton both in case of what? Aqueous and non-aqueous. Example, NH3 is a base. Why? So it can accept a proton, it becomes what? NH4 plus. Then, so according to Lewis, what is an acid? One which accept a pair of electron. One which accept a pair of electron, then it is called Lewis acid. One which donate a pair of electron, then it is called base. You see. So why the metal oxides in higher oxidation state? Higher oxidation state, they are acidic. Metal oxides in lower oxidation state are basic. Example, we will go for Mn. We know that it starts from +2, oxygen is -2, this is what +2 up to +1. MnO, here oxygen is -2, this is what +2. So it is lower oxidation state. Those metals, they are in the lower oxidation state, they are basic in nature. Okay. So if you go for Mn2O7, -2 into 7, that is -14, it becomes +14 when each Mn it becomes what? +7. Okay. So this compound is what? Acidic, higher oxidation state. Those metal oxides are in the higher oxidation state, they are acidic. Why, sir? +7 means Mn atomic number 25, +7 means it can lose 7 electron. Then in case of +7, there are only 18 electrons are there. Atomic size is very, very less. Then here you see Mn is 25, atomic number 25, it can lose 2 electron, nothing but it is only remaining 23. The comparison of what Mn2 plus and Mn +7, so the atomic size is very, very less. The size is less, nuclear charge is more, it is a tendency to accept the pair of electrons. So here you see the oxidation state is +2, means the atomic size is more, nuclear charge is less, the force of attraction is less, means the donating tendency is more, means it acts as a base. One which donate a pair of electron, it is called base, it is basic in nature. Why? +2 state is nothing but atomic size is more, or ionic size is more. The ionic size is more, why? Nuclear charge is less. But in case of higher oxidation state, then the atomic size decreases, nuclear charge is more, then nuclear charge is more, means it is a tendency to gain the electron, means it is a pair of electron acceptor, then it is called acid. Okay. So that is why those compounds, they are in the lower oxidation state, they can act as an basic in nature. Those compounds are in the higher oxidation state, they can act as an acidic in nature. We know that, so Mn it becomes what? KMnO4. In case of KMnO4, Mn is +7 state, it is acidic. Okay. So the Mn in the form of MnO, that is what? +2 means basic. If you compare Mn2O3, in case of Mn2O3 it is +3, it is also basic but less basic than this one. If you go for Mn O2. MnO2 is plus 4. So, whether it is acidic or basic, so it is an amphoteric substance. It is an amphoteric substance. MnO2 is an what? Amphoteric substance. Like that, we will go for chromium compounds. So, CrX2 is CrX2. In case of what CrX2R, we may go for CrO oxide forms. So, this is minus 2 plus 2, it is basic, lower oxidation state. If you go for Cr2O7 minus, in case of Cr2O7 minus, Cr is plus 5, plus 6, so it is acidic. Then what about that Cr2O3? Cr2O3, it is amphoteric substance. Okay. So, now we will go for V2O5. V2O5 is also amphoteric substance. What is amphoteric substance? One which acts as an both acid as well as base, then that compound is called amphoteric substance. These amphoteric substances, they can react with what? Acid as well as base. Means it can react with alkalis. This V2O5 react with base, it becomes V4 3 minus compound, hexoanion. Then it can react with acid, it becomes VO4 plus. Okay? So, this is oxocations, means V2O5 is an amphoteric substance. It acts as an, means it can react with what? Both acid as well as base. So, it can react with bases, nothing but alkalis. It can form an VO4 3 minus, it is an what? Oxoanion. Then it can react with acid, it becomes what? VO4 plus, it is an what? Oxocations. So, like that we can explain the stability of those metal oxides and fluorides. Usually we should concise that. So, those compounds, they are in the lower oxidation state. Those compounds of halides or oxides, they are in the lower oxidation state, they are unstable. Those compounds are in the higher oxidation state, they are more stable components. Okay? So, we compared, so among CuX and then CuX2, so which is more stable? So, CuX2 is more stable than that of what? CuX compounds. Okay? Then, so like that we can write the different metal halides and oxides. So, here the most, once again most important component, that is what? Why MnF4 is the maximum oxidation state with halides, but we can't write MnF7, but we can write Mn2O7, that is what? Plus 7 state. We can write the Mn in the form of oxides as a plus 7 state, but not in the form of halides. The reason is it can form some multiple bond, this does not form some multiple bonds. Okay? So, like that we can explain so why some compounds, they are in the oxides, they can act as an acidic and basic. So, those metal oxides having a higher oxidation state are acidic, those metal oxides, they are in the lower oxidation state are basic. So, we can compare those elements, those who are in the lower oxidation state, they are basic in nature, those are in the higher oxidation state, they are acidic. MnO is basic, but Mn2O7 is acidic. So, the middle compounds, they may form, means they can act as an amphoteric. Amphoteric means what? They can act as an acid as well as base, means they can react with both acid and bases. Okay? Yes. So, that is all about the stability of elements in 3D series. Okay?